Hello guys, welcome to my channel. In today's video, we are going to discuss about Kubernetes. Okay, so we'll discuss what is Kubernetes, what are the advantages of Kubernetes, and why this is needed. After that, we will discuss the architecture of Kubernetes and also the architecture of Azure Kubernetes Service, which will be discussing further and creating the AKS further and learning about that in the Kubernetes video series. Okay, so let's begin the video. If you are new to Kubernetes and if you don't know anything about it, let me just briefly tell you in easy words. Okay, so Kubernetes is a portable open source platform for managing containers. Okay, so this is a container orchestration tool. You can deploy multiple containers in it. You can manage your containers and you can efficiently, auto scale it, and you can even roll back your changes if something is wrong. Okay, so this is basically a container orchestration tool where you can deploy your containers and you can run your application inside those containers. Okay, let's now talk about advantages of Kubernetes. Okay, so there are so many advantages of it. We can deploy multiple containers in replica sets. We can create multiple nodes and multiple pods so that our Docker containers will be running efficiently and our application will be highly available. Okay, we can scale the cluster. We can enable auto scaling so that our cluster will be auto scaled automatically. Nodes will be automatically added and pods and containers will be created automatically. Okay, we don't have to do anything in there. Once the cluster is created and we have enabled the auto scaling, everything will be done automatically. Okay, so this will improve our performance of application. Kubernetes also supports high availability by providing automated failover and load balancing. Okay, so if you have some cloud provider, you can add the load balancer. It will automatically balance your load. It will automatically send all the traffic to the nodes and to the pods equally. Okay, so this will, ensure your application is highly available, or even if some container are being destroyed or they are unhealthy or some pods are unhealthy, this will help ensure no downtime and improves your application reliability and availability. Okay. Okay, so the next advantage is resource efficiency. Kubernetes optimize resource allocation and utilization through its advanced scheduling capability. There is a scheduler in master node of Kubernetes which distribute the traffic across all the nodes and pods. If there is some empty pods, then it will create containers inside that. Okay, so this helps maximize the utilization of computing resources, minimizing waste, and it reduces the cost as well. Okay, now let's move ahead. So, a very good advantage of Kubernetes is self-healing. Kubernetes, it heals itself. It will detect and address issues within an application environment. If a container or node is failed, then it will automatically deploy new containers and it will automatically deploy new nodes as well. Okay, it will replace all the failed instances or pods and nodes as well, and it will automatically start them, and it will automatically restore all of them, and it will not interrupt your application availability. Okay, so this is a, I mean, you can say like very important advantage of Kubernetes. The next one is portability. Okay, so this allows Kubernetes to easily move your application between different environments. So if you have some on-premises data centers or public clouds, or if you have hybrid setup, this also works in there. Okay, and the next one is it you can integrate Kubernetes with DevOps environments. Like you can integrate this with your DevOps CI/CD pipelines. You can keep the Kubernetes manifest files, or if you are deploying Kubernetes with Helm charts, you can keep them in repository, and you can again create the pull request, and you can review the code. You can review your YAML files, and also you can create CI/CD pipelines to automate your deployments, Kubernetes deployment, your application deployments with the help of CI/CD pipelines, and for each of the environments like dev, QA, or production. Okay, so these are the advantages of Kubernetes. Let's talk now about the cluster architecture. So this is the cluster architecture on the screen. So if you see the big diagram, this consists of a cluster. Here in Kubernetes cluster, we have one control plane and we have node pools. Okay, so this is also called master node, and these nodes are also called worker nodes. So this master node will control all the worker nodes in the backend. We have these many resources, or you can say like cloud control manager, etcd, kube api server, scheduler, or and controller manager in master node. So this will be in master node, and we have worker nodes, and in there we'll have kubelet, kubeproxy, and container runtime. That is, you can say Docker or containerd, something like that. Okay, inside this node we'll have pods, and inside these pods we can have containers. So in one node we can have multiple pods and we can have multiple containers as well. Even in one single pod we can have multiple containers as well. Okay, and in one worker node, this is a worker node. So suppose this node 1 is one worker node, node 2 is second worker node. Like this we can have multiple worker nodes based on your requirement, or based on your application capacity. In one worker node we'll have kubelet and kubeproxy along with container runtime and pods and containers. Okay, so kubeproxy will enable the networking between the worker node and master node, and kubelet is an agent which keeps your worker node active, or it helps communicate your worker node with the master node. With the help of kubelet only, this scheduler will check if any pod is empty, or any container is, not working properly, or it's empty. Okay, so let's now talk about the control plane. This is also called master node. If we see here, we have cloud control manager, etcd, kube api server, controller manager, and scheduler. We'll discuss one by one, and we'll discuss in detail as well in the next slides. etcd is a, you can say it is kind of database in key value store, where all the details about cluster are stored, like all the node details, pod IP addresses, node IP addresses, and everything about the cluster will be stored in this key value store, that is called etcd or etcd. Okay, kube api server is front end. All the nodes, even control plane, and etcd, scheduler, control manager, everything will communicate to kube api server. So this is kind of front end to uh, Kubernetes. Okay, everything will go in this cluster via kube api server. The next one is scheduler. Scheduler helps to schedule nodes, and if there is some containers or pods are empty, it helps allocate pods and containers to that particular node. Okay, with the help of kubelet, it communicates via kubelet to the pods and nodes. The control manager is, uh, it it kind of, you can say like this is a controller which will monitor the performance of nodes and cluster, and if there is any issue, suppose some node is down, it will replace that. Some pod is down, it will replace that pod as well. Okay, so this is the architecture. Now let's move to the next slide and we'll see all the thing in detail. So this is again Kubernetes architecture in simplified uh, diagram, you can say. So if you see, this is our master node and this is the worker node. In master node we will have kube control manager and cloud control manager. So kube control manager and cloud control manager both are kind of similar. This is in Kubernetes and this is inside your cloud provider. So you can take the example of Azure. So this cloud control manager will be in sync with this kube control manager. So suppose one node is down and it is removing that node, then cloud control manager will also remove that node. Suppose if that is a virtual machine, then from your Kubernetes cluster. Okay, so these two will be in sync. You can see we have kube API server in master node or control plane, etcd, the database, you can see the key value store, and kube scheduler. And this also contains container runtime that can be either Docker, containerd, or something else. Okay, here in this case, so we have worker node. In worker node, we have the kubelet and kube proxy and container runtime as well. Within this container runtime only, our pods will be created and containers will be created inside those pods. So the pod is a smallest unit or smallest thing you can create in a Kubernetes cluster. After that, you can, in one pod only you can create containers that can be either one container or multiple containers. Okay, now let's move ahead. So this is the architecture of just the master node, and we have all the detail here as well. If you see the kube API server, it acts as a front end for the Kubernetes control plane. It exposes the Kubernetes API. Command line tools like kubectl. So kubectl is a command line tool which generally we use to manage our Kubernetes cluster. You can create pods, you can create deployments, and basically you can create anything in Kubernetes with kubectl command line tool. Okay, so with this kubectl only we manage our Kubernetes cluster. So moving ahead, users and even master components, scheduler, controller, manager, and worker node component like kubelet, everything talk with API server. Okay, like we have already discussed, everything in the master node talks with this kube API server and do their work accordingly. The next one is etcd, consistent and highly available key value store used as a Kubernetes backing store for all cluster data. So this will store all the cluster data like node IP addresses of pods. So suppose we have multiple nodes, 10 nodes and suppose 200 pods, then how that will, where the data will be stored, like what is the IP address of this pod, that pod, and some nodes along with like IP addresses of services and everything. So there it comes the etcd, here all the data will be stored. Okay, it store all the master and worker node information. Now let's talk about kube scheduler. Scheduler is responsible for distributing containers across multiple nodes. Okay, so your scheduler will distribute all the containers in multiple nodes and multiple pods as well. So it keeps checking that which node is or which pod is empty, and it will allocate containers in that pod. Okay, it watches the newly created pods with no assigned node and select a node for them to run on. Now let's talk about Kube Control Manager, which we had discussed. So controllers are responsible for noticing and responding when nodes, containers, or endpoints go down. So if something in your Kubernetes cluster is down, It generally control managers checks that, and it will, I mean, bring up new containers, new nodes, or something like this. Okay, there are basically four type of control manager. One is node controller. This is responsible for noticing and responding when nodes go down. Nodes is nothing but a virtual machine, or you can say virtual machine scale sets. So if you say one node is attached to your Kubernetes cluster, that means one virtual machine or one VMSS is attached to your Kubernetes cluster. So if you create a Kubernetes cluster, generally it will create another resource group inside your Azure environment, and there it will keep all the resources related to your Kubernetes cluster, like all the nodes and everything. If you are creating something else like databases and all, it will keep inside that uh, resource. Okay, the next one is replication controller. This is responsible for maintaining the correct number of pods for every replication controller object in the system. So generally we create replica in our Kubernetes cluster. So suppose you have deployed a web server in a pod in Kubernetes cluster. So if you have used just single pod for a web server, then if something happens to that pod or that is corrupted, then your web server will go down. Okay, to minimize this, we create replica sets in our Kubernetes so that your application will not go down. Replica set means it will create replica of your pod. So if you suppose you have given replica set as 10, then it will create replica of your pod, that is web server pod. I mean train replicas of your web server pod. So even if one pod is down, other nine pods will be active and they will work for your web server, and your web server will still be accessible. Okay. Now the next one is endpoint controller. This is used to control the endpoints. Okay. The next one is service endpoints and token controller. This creates a service account and API access for new namespaces. So whenever you create a new namespace in Kubernetes, it will come into picture and it will create a default account for that namespace. Okay, namespace is nothing but a separate unit in a Kubernetes cluster. We will discuss about these in upcoming videos in detail. Okay, the next one is Cloud Controller Manager. A Kubernetes control plane component that embeds cloud-specific control logic. It only runs controllers that are specific to your cloud provider. Okay, so like how I have told you earlier, this also controls. This is also like similar of Kube Control Manager. This also control. I mean, we have like node controller in here. It will keep checking the Kube Controller Manager, or if you see read here, for checking the cloud provider to determine if a node has been deleted in the cloud after it stops responding. So if some node has stopped responding and this Kube Control Manager has deleted it from Kubernetes cluster, then it will make sure Cloud Controller Manager will make sure that that node is also removed from the cloud provider, that is Azure or AWS. Okay, the route controller for setting up routes in the underlying cloud infrastructure, service controller for creating, updating, and deleting cloud provider load balancer. Okay, so generally we create a load balancer service. If we have to create it, this service controller we will take care of creating that, updating that, or if we want to delete it, it will delete that as well. Now let's come to worker node. So master node generally controls the worker node. It will assign all the pods and everything in here in the worker node with the help of kubelet and kubeproxy. So here contains the container runtime. You can see here container runtime is the underlying software where we run all these Kubernetes components. Okay, so at this moment we are using Docker, but we have other runtime options as well like RKT, container D. We have another component here that is called kubelet. Kubelet is the agent that runs on every node in the cluster. Okay, so this kubelet will run on every node in all the machines. This is a agent, you can say, which runs all the in all the worker nodes. Okay, this agent is responsible for making sure that containers are running in a pod on a node. Okay, so this will make sure all the containers are running inside the pod, and it helps communicate with the master node and scheduler. The next one is kubeproxy. It is a network proxy that runs on each node, and it help maintains network rules for the nodes. With the help of kubeproxy, all the network traffic will go and will be coming here at the worker node. Okay, in short, these network rules allow network communication to your pods from network session inside or outside of your cluster. Okay, so we have covered the basics, you can say basic architecture of Kubernetes. Now let's move to AKS, Azure Kubernetes Service, which we will be discussing in the later videos as well. Okay, so Kubernetes is a container orchestration tool. Okay, and Azure is a cloud provider. So Azure also provide Kubernetes service like how AWS and Google Cloud provides. So the Azure Kubernetes is, I mean the Kubernetes which is provided by Azure is called Azure Kubernetes Service or AKS. Okay, so this is also highly available, secure, and fully managed Kubernetes service. Here in AKS, you will have to just manage your worker nodes, and all the master thing like control plane will be managed by Azure itself. Okay, so for AKS, still we have 36 regions and it is still growing. Okay, and if we compare to other cloud providers, AKS or Azure is having highest number of regions. Okay, so what type of workloads we can run in the AKS? Almost any kind of workloads you can deploy. That can be your microservices application or Windows-based application like .NET, Linux-based applications like Java, or any other type of application as well. Okay, IoT device deployment, machine learning model training, or anything or any application like this. This is the AKS architecture. This is almost similar as Kubernetes because of course this is also a Kubernetes, just the difference is cloud provider. Here also we have a control plane that is called master node, and here we have AKS Kube Controller Manager, Kube API Server, the Key Value Store etcd, Kube Scheduler, Container Runtime, and this whole thing is our Azure AKS cluster control plane. And here we have worker nodes where we will have kubelet, kubeproxy, container runtime, and this is called our node pools. So if you create node pools in Azure AKS, that is a virtual machine, or you can say virtual machine scale sets in Azure. So this is also architecture. You can say this is a user, and if they are deploying something or something they are doing with the Kubernetes cluster, they will reach to Kubernetes API endpoint, and this will go to Azure managed control plane. Okay, and this control plane will, I mean, create the nodes and all the pods along with containers in the nodes in worker nodes or node pools. So if you see here, we have the customer virtual machines, or this is the thing in AKS. This customer VMs part will have to manage by ourselves. Okay, these all above things like Azure managed control plane, this will be managed by Azure, and this we will have to manage it. Okay, we have to create the node pools, we will have to create the pods, we will have to create the containers, and we will have to create the service replica sets, everything in our AKS cluster, which we will be discussing in later videos. Okay, so in today's video we have covered what is Kubernetes, what are the advantages of Kubernetes, and we discussed architecture of Kubernetes, like how master node and worker nodes works, and by joining them how it makes a cluster that is called Kubernetes cluster. Okay, we also discussed about the components which exist in master node and worker nodes, like pods and kubelet, kubeproxy, API server, etcd, scheduler, etc. Okay, we have discussed everything in basic. We'll be going in detail in further videos, and we'll understand how we can make it and how we can deploy our applications in cluster using Azure pipelines, CI/CD pipelines. We will also discuss how we can create AKS infrastructure with Azure Bicep, Terraform, and deploy a simple microservices application to our AKS. Okay, so that's it from this video. If you liked it, please like and subscribe my channel. If you have some feedback or suggestions, please let me know in the comments. Thanks for watching.